So in this video we will study about the bond enthalpy. So what is the meaning of bond enthalpy? So enthalpy associated with breaking 1 mole of particular bond in a gaseous substance. So basically it is the energy associated with breaking 1 mole of particular bond in a gaseous substance. For an example, here these two green balls shows for chlorine. So this is a Cl2 gas, chlorine gas in the gaseous form, and when we have to break this chlorine molecule into its elemental form in the gaseous state, so there is some energy required to break this bond, and to break 1 mole of gaseous bond, that is called the bond enthalpy. Here is another example. This is a CH4 methane gas. Black ball is for carbon and remaining 3 white ball for hydrogen. So when methane is in the gaseous form and the energy associated to break each bond, that is called the enthalpy. Bond enthalpy means the energy required to break the bond. So, and the bond enthalpy is always positive because energy is required to break the chemical bond. So basically you are giving energy to the system, so final energy will be higher than the initial energy. That is why the bond enthalpy will be in the positive mode, and energy is always released when a bond form between gaseous fragment, and it is opposite when we form a bond, so that energy releases. So greater the bond enthalpy, the greater the bond, means the greater the bond in energy is required to break the bond will be very stable. So here is the table shows that the average bond enthalpy in kilojoule per mole. So for 1 mole of carbon and hydrogen to break is 413, and for nitrogen and hydrogen is 391, oxygen and hydrogen is 461, and fluorine is 1. So if you see this whole table, so the greatest number is here, this carbon double bond O, carbon monoxide gas, look like this bond is very stable, and there are 2 bonds, so require a lot of energy to break this one. And the lowest we can find, I think this is the lowest one, 151 kilojoule for iodine gas, so that is why iodine is very volatile. It very easily evaporate, and also it can easily break the bond, so bond enthalpy is very low for this iodine. And how we use bond enthalpies and enthalpy of reaction. So whenever we try to calculate the delta H or delta H of reaction or enthalpy, change in enthalpy in the reaction, we sum the bond enthalpies of the bond broken and minus sum of the bond enthalpies for the bond formed. So we add all the bond energies for bond made and then subtract for bond energy for all bonds broken. So for broken we need to give the energy and add the bond energy for bond made. So when we will make those bond energy releases. So how we calculate based on the bond enthalpy? If we have to calculate the enthalpy of reaction for the using bond enthalpies, so we have to add all the bond enthalpies to break the bond, and then we have to subtract the total enthalpy of the bonds to make the bond. So let's see an example here. Bond enthalpies and enthalpy of reaction. So for an example, this we can predict whether a chemical reaction will be endothermic or exothermic using bond energies also. So for an example, this is methane gas and this is chlorine gas. So energy is required to break these bonds. So in this case, one bond from the carbon and hydrogen is broken and one bond from the chlorine was broken. So delta H1 will be more than 0 because energy is required. That is why this is going up, because they have higher energy. And when this carbon and chlorine and carbon and hydrogen and chlorine bond form, that extra energy releases out. That is why delta H is less than 0 and they reach at the stable position with a new bond formation. And then you can calculate the difference between these two. If it is releasing, if it is higher, then it means this is an exothermic reaction. So energy will release, extra energy will release from the bond when we will make a chloromethane and HCl from their elemental, or when we have to react with the methane and chlorine gas to produce this one, some energy will released. So this was the example of the bond enthalpy and bond reactions. Next we study about the energy in fuel and food.